Hello, good morning, good afternoon, good evening, depending on where you are watching me from. Yeah, how you guys doing? I hope you are doing good. Okay, today we'll be talking about control theory. Our fixed idea with this example how to obtain a transfer function as simple as ABC by using Laplace transform. So I'm going to break it down for you. Is that clear? Make sure you know this particular problem. Know it more better than the person teaching you. I want you to know this particular problem more better than the range of maths. Is that clear? Okay, well before we do so, let's just pray for a few seconds. Just pray for retentive memory and understanding. Just pray to your God. 2 seconds. We are in prayers. Amen. Okay, yeah. If today is your first day meeting me here, please go to Google, type range of maths. Amen. You will see a lot of solved mathematical problems, not only solved problems. You will also see comprehensive lecture notes for those who are preparing for YA JAM, ND, HND, BSc, MSc up to PhD level. You'll see mathematics lecture notes. It will help you. Make sure you share this video. Thank you and God bless you. Okay, here is the question. It says if d square y over dt square, amen, plus a1 dy over dt plus a naught y equals to b naught u with boundary conditions. Y naught is equals to y of 0 is equals to y naught and y prime of 0 is equals to y1. We said obtain a transfer function as simple as ABC. How can you obtain a transfer function? Note that this is a second order differential equation. True of us. Let's write solution first. Amen. Okay. Here we have d square y all over dt square plus a1 dy all over dt plus a naught y equals to b naught u. Okay? Yeah, with boundary conditions, we have the boundary conditions y of 0 is equals to y naught and y naught of 0 is equals to y1. Amen? Is equals to y1. Okay. Yeah. So for us to obtain our transfer function, transfer function is given as g of s is equals to y of s, amen, all over what? U of s. Is that clear? This is a transfer function. Not necessarily it must be y of s, u of s. You can use any variable, but make sure the variable must be defined. Okay, so if you agree with me, how can we solve this differential equation to obtain our transfer function? What we need to do here is for us to say we write using or take Laplace transform, take Laplace transform on both sides, amen, Laplace transform on both sides, as simple as ABC. Okay, so if you agree with me, it means a Laplace transform will now be Laplace of d square y all over dt square, close bracket, plus a1 is constant, so you write it a1, then Laplace of dy all over dt, amen, plus a naught is constant, you write a naught Laplace of y, amen, then equals to B naught is constant. B naught, you write Laplace of U. Amen. Okay. So let us note that this is a second order derivative. Note that Laplace of d square y all over the t square, amen, is equals to s square y of s, amen, minus sy of 0 minus y prime of 0. Take note. Also, Laplace of first derivative dy all over dt, amen, I hope I'm not rushing you, is equals to sy of s minus y of 0. Yeah. So this implies that anywhere you see this and this in this second order differential equation, you are going to substitute in for this. Then when you see Laplace of y, this is the same thing as y of s, and also Laplace of u is the same thing as u of s. Take note. Okay. So instead of all this, we are going to replace them with this one. Is that clear? So let's write. We will first start with this. This is x squared y of s, amen, minus sy of 0, then minus y prime of 0. Then what we have here, plus, mind you, this is what? A1, then we must create a bracket for this Laplace transform of first derivative, sy of s minus y, amen, minus y of 0, close the brackets. Then here is a naught, amen, you open bracket of, okay, it's not necessary, yeah, Laplace of y is the same thing as y of s, amen, then is equals to b naught Laplace of u is what? U of s, amen. Okay, so if you agree with me, not be so, not so, yeah. So if we have to multiply out these brackets, so here will be s squared y of s minus sy of 0 minus y prime of 0, amen, plus a times sy of s is a1 sy of s, then minus a1 y of 0, then plus a naught y of s, amen, then equals to b naught u of s. Yeah. Okay. So far so good. Yeah. Are you seeing what I'm saying? So at this point, what we need to do here is we collect like terms. What do I mean by collect like terms? Yeah, the ones having y and the y of s, sy of s will be on one side. That is, what do I mean by that? Okay, before we do that, let us recall the boundary condition first. Look at the boundary condition. The boundary condition says y0 is equal to y0 and y prime 0 is equal to y1. So for that we are going to obey the boundary condition. So anywhere you see y0, you write y0. Is that clear? So here we are going to write amen, minus sy of 0, then minus y prime of 0 is what? y1. So here we are going to write y1 instead of y prime of 0, then plus a1 sy of s, amen, then minus a1 y naught is given as what? Y of 0 is equals to y naught, okay, plus a naught y of s is equals to b naught u of what? S. Okay, I want to clean this up so that it will contain everything. So far so good, amen. Here we are going to look at, we will collect like terms, that is this, amen, yes, okay. Oh, I will do not substitute here for this, why not? So here is supposed to be sy naught, true or false? Yes, here is supposed to be sy naught, so yeah, sy naught. Okay, let me just rewrite it up so that let me clean this and rewrite it up so that you won't be confused. Is that clear? I hope you are following me. Okay. Okay, let's record back the boundary condition. We write s y of s, amen. Then this is y sy naught. Our boundary condition y naught is equals to, so here will be minus sy naught, amen. Then here will now be sy prime, the boundary condition is what? y1 minus y1, hope I'm correct. Then here will be a1s, okay, a1 plus amen, plus a1 sy of s, okay. Then here will be y naught is y of 0 is equals to y naught. So here will be minus a1 y naught, then plus amen, plus a naught y of s is equals to b naught u of s, amen. Okay, so as I was saying, I said we are going to collect like terms. If you can see what I am saying, amen. Are you seeing what I am saying? Okay, so this this now we can write it this way: s square y of s, then plus a1 sy of s, then plus a naught y of s, amen. Okay, so then if this crosses the sign of equality, becomes what? Plus, this crosses the sign of equality becomes plus, this crosses the sign of equality becomes plus. So here will be equals to b naught u of s, then this will now be plus s y naught, then here will be plus y1 and plus y1, a1, amen, a1 y naught. So what is common here? Look at the left hand side. We factor out what is common. What is common here is what? Y of s. So y of s, open bracket, s square plus a1, amen, s, a1s, yes, plus a naught, amen, will now be equals to b naught u of x plus sy naught plus y naught plus a1 y naught. Okay? Yeah. So if you agree with me, can I take off these parts? Okay? So for us to obtain our transfer function, we have to divide through by s squared plus a1s plus a naught. So the left hand side will now be y of s, now be equals to b naught of u of s plus sy naught plus y1 plus a1 y naught all over s square plus a1s plus a naught. Okay? Yeah. For a function to be transform function, what we need to do, it means the boundary conditions or the initial values must be 0. What do I mean by that? It means y naught is must equals to 0 and y1 must be equals to 0. So if you agree with me, it means we are going to substitute in zeros here. I can clean these parts. Yeah. So now our transfer function will now be equals to our initial value condition. Must be 0. So b naught u of x remain plus here is 0. So 0 times x is 0. Okay, let's just put it this way for the sake of Malians. Then here is what? 0. Then plus a1 of 0 all over s square plus a1s plus a naught. So therefore our y of s will now be equals to, all of this will be 0, two of us. So we'll be left with b naught u of s all over s square plus a1s plus a naught. This is what they want us to obtain, and this is known as what? The transfer function. So should in case you come across questions of this one, always remember, after solving up to this stage, recall that the initial value must be equals to 0 for a function to be a transfer function. So take note of this. So this is how you are going to solve it. If you have any challenge, drop it on the comment section. I'll look at it and get back to you. Thank you and God bless you. Make sure you share this video. See you in the next video. Bye.